¿Cómo están? Y hoy vamos a switchear de repente con nuestra comunidad que está ahí dando vueltas por todos lados. Vamos a switchear, vamos a hablar en inglés por un rato, por esta meetup que nos tocó. Vamos a pasar al English. So welcome all, if you're seeing this meetup from other part of the world, welcome. We are RubySur. We are an organization of Ruby developers here in Argentina. We have an Uruguayan here as well. But we're mainly from Argentina, and we would like to have all the Rubistas and the Rubist people here with us, enjoying talks and sharing knowledge with all the community. If you haven't heard of us, you can click in the link in the YouTube channel and see all of the previous chats and meetups we have done. We've done on-site meetups, and this is another type that it's online. So we tend to try to have different speakers from different companies or different professionals speaking. So I hope you enjoy this. And this new version, this is the first English edition of the Ruby meetup from Latam and from Argentina. So I hope you enjoy it first of all, and always we have to, and we want to appreciate the effort and support of our sponsors. So we have Wagon, that also today we have the founder of Wagon Latam speaking for us about innovation and technology, and to Synaptia as well, that has joined this last time.
Yeah, last month.
Yeah, last month or 2 months ago, they joined us with support as well. So thank to them. Thank you for Ombulabs as well. And I'm forgetting Roostrap because here we are doing the headquarters in Roostrap offices. So thank you for the space and always welcoming me, especially like come here to invade the space. So thank you for being here. We are Gema from Wagon,
Ariel from Ombulabs,
Enzo from Roostrap,
Santiago from Roostrap,
Doi from Roostrap.
Cool.
and we also have Joaquin here helping from.
That is in the backstage from Italy. So I hope you enjoy this, and we want to welcome our first.
Wait, one
Cool.
thing. Oh, that chat is working?
Yes.
Oh, okay.
I think.
Thank you, Joaco.
Thank you, Waco. She's doing a great job, and at late hours there in Europe. So thank you very much. So with all this said, we want to introduce our first speaker that he was very waited.
Yeah.
He was very waited. So thank you for being here, for joining to our maybe people will need to refresh the window. Yes. So thank you for joining us, and I present to you Jason Swett, that is going to be talking about testing. So here, welcome, Jason.
Gracias, muchas gracias. Hola a todos. Me llamo Jason Swett. Vive en Michigan, en una granja en Estados Unidos. Estoy muy feliz para hablar con ustedes. All right, I don't really speak Spanish, so I'm going to switch to English now. But thanks a lot for having me here. I'm going to talk today about testing. You might know that that's kind of my thing. And we're going to explore a very fundamental question today, which is, what is testing? And we have this chat here. I see some people are already chatting in the chat. And as we go, it would be cool if it could be kind of interactive. Feel free to type in any questions you have at any time. But my first question for you is, what is testing? I know it's kind of a big question. And it's kind of like, what do you mean, what is testing? It's kind of a hard question to answer, but I like to ask these difficult questions and pose them to ourselves and see what we can come up with. So, what is testing? I don't see a lot of answers coming through just yet. I'll give you a few seconds to think about it. Okay, here's my answer as to what testing is. Oh, here we go. Thank you, Patricio. Testing is feeling confident your code won't break. Indeed. So in exploring the question, what is testing? Let's ask the question, what is a test? To me, a test is an executable specification. An executable specification. I think test is actually the wrong word. They aren't really tests. They are specifications. And test-driven development is because again, it's not really about testing. It's about specifying the behavior that we want, and it's about making our code conform to our specifications. And there's, I want to make a distinction, a really, really important distinction between specification and verification. Maybe you guys have heard this distinction before. Bob Martin has said that testing is not about verification, it's about specification. The example that I use sometimes when I talk about specification and verification is, let's imagine that you have a factory. And in this factory, let's say you make squirt guns. And as the squirt guns come off of the factory line, you inspect each squirt gun. And you have a discard pile. If you test a squirt gun and it's defective, then you toss that squirt gun in the defect pile. This is a kind of testing. This is verification. We're verifying each individual squirt gun. We're saying, does the squirt gun work? And when we do this, the target of our scrutiny is an individual squirt gun. It's the artifact that comes off of the factory line. That is not the same thing as specification. When we have a specification mindset, we can go into the factory and we'll do the same thing. We'll grab squirt guns off the end of the line and test the squirt guns. But when we're thinking about specification, the target that we have in mind isn't the individual squirt guns. What we're targeting instead is the design of the system that manufactures the squirt guns. So same artifact, but different target. In the verification mindset, sorry, I'm reading the comments here. It's making sure that the core or not so core behavior of the software is correct when implemented. Yes. So verification, we're looking at the artifact. Specification, we're still looking at the artifact, but targeting the design of the system. And what do we do again if we're testing an individual squirt gun and it's defective? We toss it in the discard pile. That's if we have a verification mindset. But if we have a specification mindset instead, we come across a defective, we sense a defect when we're examining the squirt guns. What do? We don't throw away the squirt gun because that's not our target. Our target, again, is the system that manufactures the squirt guns. So if there's something wrong with the squirt gun, that tells us that something is wrong with the design of the system. And so what we need to do in response in that case is not to throw away the individual artifact, not to throw away the squirt gun. It's to change the design of the system. So this is a really important distinction. And how does this analogy map onto programming? So a software system is a factory. It's kind of a strange kind of a factory, but it does map. In the factory, the code in any application is the factory machinery. And the products, the individual products that come out of the factory, those are individual web pages. So making an HTTP request in a web application is kind of like placing an order for a product. And this is, imagine a very adaptable factory, a factory where they can manufacture almost anything, and they can build it to your specifications. Kind of like, I don't know, you can order, you can order a Tesla from the Tesla website, pick your spec, that specific Tesla just for you. It's kind of like that. You send your HTTP request, that's an order for the factory, and the factory puts together a response based on your request, and it sends it to you. And that response you get back, that's analogous to the squirt gun. And a lot of developers, when they're thinking about automated testing, they get a little bit mixed up. They think of testing as testing the artifact. Just like a QA person might do, you might go to a production website and you might load individual pages and click around on stuff and make sure it's working. But that's not actually the target with automated testing. You see tests that make assertions like, make sure that all the right fields get returned from the HTTP response. That's kind of the verification mindset. That's the mindset of scrutinizing an individual page return, an individual HTTP response, an individual page load. But that's not what testing is about. We're not testing individual page loads. We're testing the design of the system. again, we're not testing individual squirt guns. We are testing the design of the machinery that makes the squirt guns. In both scenarios, we happen to be using the squirt gun as the thing we scrutinize. But when we have a specification mindset, we're only using the squirt gun as a proxy. Where we can't test the design of the system directly. So we use the squirt gun as a proxy. We're looking at the design of the system via the squirt gun. I'm going to pause there for just a second. And if anybody has any questions or comments, feel free to share in the chat there. So this distinction between specification and verification is kind of nuanced, and it's kind of hard to communicate, but it's one of the very most important principles of automated testing. I had a thought and I lost it. Thinking. I don't remember. Moving on. You have probably, okay. Maximo Marino says, what needs to be tested or specified? That is an excellent question. Okay. This is a very common question too. And it's a very good question. Let's talk about that because it's very related to this idea of tests as specifications. One of the biggest mistakes that I see in programming is programmers not deciding what to do before they do it. They have kind of a vague idea of what they want to do, and then they just like start typing. But that's not likely to lead to success. It goes more smoothly if you decide what you're going to do before you do it, to an appropriate level of specificity. So before, let's try to come up with a concrete example. What kind of a program might we write? Right now I'm working on a CI platform, but that's maybe not the greatest example. Can somebody give me an example of a program we might write? Because I'm kind of blanking on examples. Here's an example, a word processor. We want to write like Google Docs, the equivalent of Google Docs, but like a really simplistic version of it. And so I come up with some specifications for my word processor. For the first iteration of my word processor, I want to do the simplest possible thing that I can do. Let's say that I want to be able to type in the word hello, and I want to be able to save it. I type hello, I refresh the page, and the word hello is still there. No bold or italic or any other rich text editing or anything like that. I can just type in some text and click save, and it persists it. That's all. So I can write that down just like on a piece of paper on my desk. I can write step 1, visit the page. Step 2, click on the text field. Step 3, type hello. Step 4, click save. Step 5, refresh the page. Step 6, assert that the text box that I just typed hello into still says hello. That can be the entirety of my specification for my first version of the program. And to come back to your question, Maximo, that's an example of the kind of thing that would be specified. Notice that this specification takes the form of a manual test that I could perform. So I could load up my web page and take my piece of paper where I wrote down these specifications, and I could just follow that, visit the page, type the thing in the box, blah, blah, blah. It can be a manual test. So test-driven development doesn't have to be automated test-driven development. It can be manual test-driven development. And again, test-driven development is the wrong word. Maybe specification-driven development would be better. So we can start with that specification and perform our manual test and keep building our code until our test passes. And we never even need to write an automated test if we don't want to, and it's still TDD. But of course, if we do want to, and pretty much always I do, we can take that specification and capture it in an automated test so that we don't have to manually perform that test over and over. We can have the computer do it for us. So that's one way to answer your question, Maximo. I do, if I may do a plug, I go deeper into that question in my book, Professional Rails Testing, which is available on Amazon. Gaston. I'm going to say Gaston. Hi, Jason. What are your favorite gems that you use for testing? First of all, I don't like to emphasize tools and gems and libraries and stuff like that. I like to emphasize principles, because principles are timeless and portable. So I want to say that up front. Having said that, I typically use RSpec as opposed to Minitest, not because I think it's better, just because that's usually somebody else picks for me. And so I end up using what they use. So RSpec, and then Capybara for browser manipulation. What else? Those are the main two. I'm sorry about the pronunciation. I'm going to get almost every one of them wrong probably, but Ariel says, what do you think about the behavior-driven development term? I am a fan. I recently had Dave Farley on my podcast. If you guys don't know about Dave Farley, I highly recommend checking out Dave Farley, and especially his book, Modern Software Engineering. But I thought of him because I understand he's a fan of behavior-driven development also. My understanding of the idea behind behavior-driven development is that you're starting from a high level of abstraction, and you're starting from the user's perspective. And so you're not starting by talking about low-level nuts and bolts. You're talking about the high-level objective that you want to accomplish. So going back to that word processing example, what do I want to accomplish at a high level? I want to be able to type some words into a document and click save and have it get saved. I'm not talking about specific methods and stuff like that. I'm talking about the big picture. I think the software development world could use a lot more big picture thinking and thinking from the perspective of the user. And if that's what you think of behavior-driven development as being, then I'm a big fan of that. I'm happy to take more questions as we go. I'm going to go back to the main thread a little bit. If you've heard anything about TDD, you're surely familiar with the red-green refactor loop. Most TDD education starts off by teaching the red-green refactor loop. I think the red-green refactor loop is fine and good, but I don't think it's actually a great place to start. Here's a better way to start. It's something I came up with, which I call the specify, encode, fulfill loop. So the reason why I don't like to start with red-green refactor is red-green refactor is you start with a failing test, then you write the code to make it pass, and then you optionally perform some refactoring. But it trips up beginners because it's like, okay, start with a failing test. Like, why do we write a test when we know the test is going to fail? That's like counterintuitive. And then the refactor step of it is like, I actually don't refactor most of the time. Like most of the time, it doesn't really apply. I absolutely do refactor, and that's it's one of the huge benefits of TDD, and I think it's really important, but I don't involve it in every single iteration of the red-green refactor loop. So I don't even think of it as the red-green refactor loop. Here's what I think is better, the specify, encode, fulfill loop. So the first step is specify, come up with your specifications. We can continue to use the same example, this word processor. I come up with my specification, load the page, type in the text, hit save, refresh the page, assert that the same text is still present. That's my specification. And again, that specification can be on a piece of paper, it can be in my head, it can be in a note on my computer, whatever, the format doesn't matter. That's the first step, specify. Then we take that specification and we encode it in a test. So that's the second step, encode. We capture our non-executable specification that's just in our heads or on paper or whatever, and we make it executable by encoding it. A way that I like to do that is by just writing down all the steps that I would perform manually. Again, load the page, type in the text, blah, blah, blah. I'll write all that stuff down. I'll put it in a test file in the form of comments, and then I'll try to convert each line one by one. I'll convert it from a comment to working code. And then once I've done that with all the lines, I have a working test. I will have encoded my specification in an automated test. So specify, encode, fulfill. Those are the first two steps, specify and encode. The last step is fulfill. So after we've come up with our specification, and then we've encoded that specification in an automated test, then we fulfill that specification by writing the code that will satisfy that test. And I think once you put it that way, specify, encode, fulfill, then it becomes very logical and natural that we would come up with a specification before we fulfill the specification. How could it be any other way? And that takes out that counterintuitive aspect that we run into with TDD. Okay, a couple other questions. What about Capybara? Do you use that gem for BDD, or what else do you use? I mean, I just use Capybara for browser manipulation. I don't really know how else to put it. What do you think? A question from Joaquin. What do you think about TDD on the vibe coding era? Will test specifications be replaced with prompt specifications? That's a very interesting and very good question. I have so I mentioned principles versus libraries and stuff like that. Technologies will come and go, but principles are forever. And at this point in history, technology is changing so fast. And I think it's probably kind of a one-way ticket. You know, things will be changing faster and faster forever, and it's never going to go the other direction and become slower. And so we have AI now, and AI is getting better and better. We can give it just a prompt, and it can write a whole entire program for us. I watched Jason Charnes at my conference in City Ruby. He did a vibe coding presentation where he just gave a few prompts, and AI wrote an entire program for him. He hardly had to touch it, and it was really impressive. And these technologies are only getting better. But that doesn't mean that the principles of testing become invalid. And what are those principles? So, principles of not just testing, but software development in general. Talking about TDD, one of the rules of TDD, although I don't like to call it a rule, is don't write code without first having a test for it. And what's the reason for that? Well, if you write code without first having a test for it, then you risk having code that's not covered by tests. And then if you refactor, you can break that code that's not covered by tests, and it'll fail silently because you don't have tests for it. So if you break that code, you won't know until it hits production potentially. And that's a principle that is never going to change. So if you code via AI and say, write me a program that does such and such, but you don't have tests for it, then down the line, when you need to make a change or you want to refactor or whatever, you're not going to have full test coverage. You might have no test coverage. And so you'll be very liable to introduce bugs. And so the benefit of having good test coverage doesn't go away just because we have AI. And even if AI is so good that it can make changes for you without introducing bugs, you better hope that you'll never ever have to have a human understand the system. Because if the day comes when you have to make a change and for some reason AI can't make the change for you, you're going to have a human understand the system. And if AI wrote all the code and there's no tests, then you're probably going to be in trouble. So here's where AI fits into the picture for me. I'd love to have AI write the tests. Currently, AI is not always great at writing tests, but it's getting better, and most of the time it's pretty good. I've been coding in Python lately, and I'm not a Python guy, I'm a Ruby guy, but I can tell Claude, which is what I've been using, I can tell Claude, write me a test that does such and such. It'll usually do a pretty good job. I'll have to make some tweaks on my own, and that's where it's valuable to know these principles yourself instead of just blindly trusting AI. But I can say, write a test, and then I can run the test and watch it fail, and then I can tell Claude, write the code to make this test pass. And I can just repeat that. It'll give me the code to make the test pass. I'll commit that, and then I'll say, give me a new test that does such and such. I'll run that, feed it back the error message, and it's great. I think of AI as like a mental lubricant. It just makes everything go so much faster. I don't have to, like, especially when I'm working with unfamiliar technologies, I don't have to look up all kinds of Python syntax. I can just, AI will just smooth out that part for me, and I can go so much faster. So I do think they're valuable in the coding picture still, but we have to be thoughtful about how we use it, and we have to use it in a very specific will get ourselves in trouble. Okay, so I was planning to keep it to a maximum of about 30 minutes, and I think we are at about the 30-minute mark. But if people have questions, I'm happy to take just a couple more minutes of questions. Joaquin has another question here. If you were going to pair program with AI, would you prefer to write the tests and let the AI write the code, or vice versa? Good question. Great question. I know for absolute certain what the answer is. If I could only control one of the two, I would absolutely choose to control the tests. This is another thing that Bob Martin said. He said, if I had a software system and I had to choose between getting all my tests deleted and getting all the application code deleted, I would choose to have all the application code deleted and keep the tests rather than the other way around. Because if I have the tests, I can rewrite all the application code. But if I only have the application code, it's going to be really hard, if not impossible, to rewrite all the tests. The tests are the most important thing. The tests are the backbone. Again, the tests are the specifications. The tests say what the program should do. The code says what the program happens to do, but the tests say what the program should do. The tests are the ultimate source of truth. And because the tests are the ultimate source of truth, that's the part that I would want control over. The tests are the boss, and the code serves the tests, not the other way around. And so again, the tests are the part that I would want to have total control over. I wouldn't trust AI to write the tests or the application code. I don't think the technology is good enough. It makes too many mistakes. So even though I would have, let's see. Yeah, I would write the tests and AI would write the application code. I would still have to make tweaks and stuff like that to the application code. But if you're going to make mistakes anywhere, I'd rather have it be there. And you can only get so far off the track if we have the requirement that the tests always have to pass. Okay. 2 more questions. Maximo says maybe a few comments on test coverage. I don't pay attention to test coverage numbers. And I talk about this in my book too. I prefer habits. So if you have good testing habits, then the test coverage comes naturally. If you make test coverage the target, it's really the wrong target. Test coverage can only be a rough proxy for how well you're doing. Test coverage can't tell you anything about the quality of your tests. And it's really, for me, it's pointless to pay attention to the test coverage, because I know that if I write the test first, then I'm naturally going to come out with pretty good test coverage. And if I don't have good enough tests, if I don't have enough test coverage, it's usually going to be pretty obvious. I don't need a number to tell me that. I can tell by the pains that I will feel from lack of test coverage. Okay, Ariel says, where would you start adding tests for an app that has no tests at all? This is really hard. Testing is hard enough by itself, even in greenfield development, or I should say learning testing is. But adding tests to an application that already exists but doesn't have tests is a whole distinct skill unto itself. Because to do that, you have to be very comfortable with testing, but then you have to also, on top of that, be familiar with these techniques for working tests into this existing application. And the big obstacle that you usually run into is entangled dependencies. In order to write a test for something, in order to write a test for a piece of code, you have to be able to run that test. You have to be able to run that piece of code somewhat in isolation. And usually when an application has been written without tests, much of the code is very tightly coupled. And so it's not possible to pull out pieces of code and run them in isolation. And so it's dangerous to change the code before you have tests, but you have to change the code in order to write tests. And so it's this catch-22 situation. And there's techniques for that. Rather than going deep into that now, I'll recommend another book that has a lot of those techniques. Working Effectively with Legacy Code by Michael Feathers. That's a great one for adding tests to an existing application, and it's just a really good book in general. Okay, I'm going to wrap up now. What I want to leave you with is that a test is an executable specification. So really, my advice is to really internalize that idea of tests as specifications. And I again want to leave you with this idea of the specify, encode, fulfill loop. First, make your specifications, then encode those specifications as automated tests, and then fulfill those specifications. Lastly, if you want to contact me or learn more, there's my book, Professional Rails Testing. You can find me at codewithjason.com. I have a podcast called the Code with Jason podcast. My email is jason@codewithjason.com if you have any questions about testing, and I'm Jason Swett on Twitter. Thank you very much.
Cool. Thank you, Jason, for being with us. Thank you for sharing your knowledge with us today, with the community. So we don't want to hold on to you any longer, so you can go do your life. I know you're in a different time zone, so thank you again for this. I hope you can join us again another time.
Thanks so much for having me.
Cool. Well,
Thank you, Jason.
Bye. I hope you guys enjoyed Jason today. So he's leaving now. And up next, we have Latam founder. I want that book. Okay, we're going to leave all that information in our main page. If you haven't checked the new design, you can go to
ruby.com.r
to check their new website we have, and then you have all the previous talks and information about our speakers. So we're going to be posting the Jason information and book and page there as well, so don't miss that. And I'm honored to present to you Sebastián Buffo Sempe. He's the founder of Wagon Latam. He's going to be talking about innovation in this field. So here,
I think we can switch back to Spanish.
No, because he's going to talk in English.
Okay.
Piggy in your face. Wait.
Whatever you want, Seba.
See, unmute. I think you have to unmute the first time. Yes.
Hi everyone, thanks for having me. I don't know if you want me to do it in Spanish or English. I don't mind. For me, it's exactly the same.
We can let the crowd decide as well.
I don't know if there's English speakers in the crowd, so
If there's any English speakers,
I think we
speak
are.
now.
I think we are all the usual Argentinian people. So
whatever it's best. I mean,
we always have subtitles in English on the stream later. So
Okay.
if you want to go to Spanish, it's fine.
All right, so I mean, I don't mind. I can do it in English if it's better.
Supongo que no, dice la gente.
Well, I guess everyone's doesn't matter.
Podemos switchar al español si están cómodos más con el español.
¿Switchar es español o es inglés?
Podemos cambiar al español. Sí. Déjame spanglishear. Ok.
Bueno, hacela en Spanglish.
Spanglish, okay.
The usual suspects. Ok, bueno, les dejo con Sebas que ahora va a presentar. Te voy a dar.
Bueno, ¿la hago en castellano o en inglés?
Como vos quieras.
Luego, como te sientas cómodo.
Hay diferentes.
Sorprendernos.
La hago en castellano, me imagino, porque la gente habla castellano. estamos en...
Acá están diciendo en el chat español, así que vamos con versión español. Nosotros nos retiramos y los dejamos con Sebas.
Bueno, se fueron, pero quería agradecerles por venir organizando esto. Sé que la última estuvo tremenda. Y también por empujar a que más personas vengan a dar este tipo de charlas. Y haberlo traído a Jason Swett, sé que es un crack, así que de mi lado por ahí va a ser una charla que no es técnica. Tiene una parte, no es técnica, sino que es un poco contarles mi experiencia. Voy a ir brevemente, si esto funciona, Gem. Creo que se ve ahí. Denme un segundo que tengo que ver cómo se agranda esto. Ahí está. No. Bueno, les cuento quién soy y el porqué de esta charla y un poco el por qué le dije a Gema de darla. La charla se llama When Business Meets Technology, porque pensé que era en inglés. Y les cuento el porqué del nombre. Yo estudié ingeniería y después laburé 5 años en Latam Airlines, una aerolínea. Y me empecé a acercar al mundo de la programación a través de las macros, Visual Basic, hacía modelos estadísticos y más automation. Y empecé a estar muy cercano a los equipos de desarrollo de software. Es decir, yo desarrollaba, si quieren, de cierta manera, un software en Visual Basic o en uno que otro programa. Y lo que me pasaba era que la empresa lo necesitaba y iba y contrataba empresas de software para que transformen lo que habíamos creado de cierta manera o el concepto en software puro y duro, que es un poco lo que hoy vemos por detrás. Así que en un momento decidí aprender a programar. Ahí lo hice en Wagon, 2017, en Barcelona. Wagon es una escuela de programación. Arranqué de cierta manera, no encontraba manera. Por ahí un poco mi frustración era que quería estudiar ingeniería informática. Yo había estudiado ingeniería. Tenía que estudiar 4 años para estudiar ingeniería informática. No me cerraba. Encontré cosas de 2, 3 años. Tampoco me cerraron. Dije, bueno, veo a ver si esto funciona, que son 2 meses o 4 meses. Lo hice y cuando volví a la Argentina, uno de los desafíos, incluso no estaba en Argentina, pero uno de los desafíos que me propuse cuando terminé el programa era ver si había aprendido a programar y además crear mi primer